Good afternoon, good evening, good morning. Welcome to EIG's 54th webinar, a discussion with our guest experts from the industry, Dr. Mark Sneeringer of Sigmax and Dr. Ramesh Jain from SigmaMagic. And we're looking forward to an interactive webinar from each of you. So please be ready to type in your comments in the forum. And thank you for joining us again. We appreciate you taking the time, especially with everything going on, and we hope that your family are happy, healthy, and safe. This is the first webinar that we have launched in the statistical analysis intelligence area and to generate informed decisions. Our webinar series will be to accelerate the ability to make informed decisions to solve problems in the most efficient and effective manner possible. So we all have done statistics, and the question is, are we doing them in the right order at the right time in the right place? So that's what this webinar is going to be about, and how SigmaMagic has solved that particular issue. We're going to have polling throughout. We have our first poll here questioning what software do you use today? Please go ahead and type in throughout the webinar, and then we will, throughout the webinar, we'll have some additional polling questions. Some background on myself and EIG. EIG is a group of companies, about 50 companies, consulting companies, and SaaS providers that have been vetted as best in class. EIG serves as to be that master integrator to provide you access to the best and brightest companies. We're like a Swiss Army knife. Our team is dedicated to empowering your organization's workforce by leveraging EIG's partners' tenured thought leadership expertise. Our goal is to meet or exceed your expectations with customized, predictable, sustainable, and repeatable 90-day action plan programs. Overall, of course, this webinar here, where we're focusing on SigmaMagic, we're again bringing you tools to enable you and your workforce to do what you need to do in the shortest amount of time in the right way. And with that, we're going to have some introductions. Mark, you want to kick us off?
Sure. I'm Mark Sneeringer. Do some consulting in the continuous improvement area. Was one of the original rollout of master black belts at GE when we started the Six Sigma initiative there. Moved on from GE to Philips, where I ended up, my last position there was I was the continuous improvement leader for their healthcare division. I work with companies on Six Sigma deployments, a lot of work on new product introduction, and also some lean deployments.
Excellent. Excellent. Thanks, Dr. Mark and Dr. Suresh.
Yeah, thanks. Good morning. My name is Suresh Jairam, and I'm currently the managing partner for Rapid Sigma located in Bangalore, India. I have a degree in engineering and an MBA with about 20 years of experience working in India and the US, primarily at the Caterpillar and Philips. I've been a black belt, a master black belt, deployment champion, trainer, coach, head of business excellence, a lot of different hats. I'm passionate about Lean, Six Sigma, and data analytics, and I look forward to interacting with all of you today. Thank you.
Thanks, Suresh. So as you can see, we have a great panel here to answer any questions you have on statistics and analysis, and we look forward to your questions and comments throughout. With that, I think we'll get started. But before we get started, just to mention, we do have some upcoming webinars next week and the following week, so look out for those webinars in supply chain risk management and supply chain management. And so please do look out for those webinars upcoming. With that, this is the first of a webinar series. We're looking to do additional webinars dependent on your feedback. So this one is a general overview on generating data-informed decisions with analytical intelligence. In our upcoming webinars, we'll be focusing on overcoming common analytical intelligence challenges building meaningful multivariate analysis with discrete and continuous data, and or building robust surveys and determining conclusions with limited data. So with your feedback, we may reorder these, maybe adjust them slightly, but this is how we were looking to roll out to show you the power of SigmaMagic that can help. With that, we'll get started. Our agenda today is first to look at the desktop statistical applications evolution. Then we'll get into a little bit of the challenges of these applications for the masses, and then facilitating statistical use by the masses. So really we're moving, this webinar series is about how to ensure that you're using the right application, especially for those folks that aren't using the software all that much. And that's what the SigmaMagic is meant to provide, is that analysis intelligence to help those starting out on their journeys and maybe using these tools infrequently. And then we'll have a demo at the end. So with that, if we don't have any questions, I'm going to move on to our first area, which is the desktop to statistical applications evolution. So the evolution of statistical analysis packages, we start here in the 1950s into the 1975 era, where everything was hand calculations, logged tables. I don't know if many of you got the opportunity to use log tables. It does move a little bit slower than computers. A lot of formulas at that time. Elliott was helping out in building computers back then, and they were kind of the beginning of it all, as well as IBM. And we all know the Hidden Figures story with IBM. Those were some of the biggest computers of the time in the 60s as that grew. And of course, it was used a lot in different areas in agricultural research, regression, fitted standard, social sciences, ANOVA, analysis of variance, and principal component analysis. So as the time progressed, we're moving from hand calculations, computers to perform routines, and then comprehensive tools for users, and then ease of use, decision support. So Mark will get into that more in detail in a few minutes. But it's been a long evolution. It used to be only a very few people could use these tools, and now it's grown. And then what happened from 1975 to 2000, at the same time, was all these little computers. I grew up on a Radio Shack TRS-80, floppy disk. The Hewlett-Packard had a computer. Everything was floppy disk driven. Then the Mac came out. We were doing a little bit of stats there. And then, of course, Windows and the PCs came out, the IBMs, and then started introducing Excel, which ended up being used quite a bit versus in the beginning, it was IBM SPSS. You had to have a mainframe, a VAX or a UNIVAC computer, or if you were really lucky, you had a Cray, where you're doing some very complex computations. Now, what you used to do on a Cray, which was the most expensive computer in the world, you can now essentially do almost on your laptop computer. So things have changed dramatically, and we're using these tools in everything that we do every day. And now we've moved from Minitab to Excel. Excel has gained traction. Now there's Tableau, Python and R, which we'll talk about later, and business Power BI. That's where the world is moving towards today. So the supercomputer of yesterday is nothing compared to the supercomputers of today. With that, I'll turn it over to Mark.
Okay, so George Towery of Quantifying Health examined over 40,000 medical research papers over a 5-year period that mentioned that had used the statistical package. What he found was that in that area, IBM's SPSS was the most popular, used in about 40% of the studies, followed by R and PRISM in about 21 and 17% of the studies respectively. So what you'll see is that programs like JUMP and Minitab were minor players in this area where more expert-focused applications are mostly used. On the other hand, G2 analyzed commercially available statistical software and products such as Minitab, JUMP, and R, and they're the definite leaders in terms of market presence and customer satisfaction. They're also trending upward faster than the more established but expert-focused platforms like SPSS or SAS. So this points to the popularity of these products designed more for the non-expert user, the kind of user most often involved in, say, a process improvement project within a business. So if the next slide, Jim, the desktop statistical applications, so the ones that started on those very simple PCs quite a while ago, they have definitely evolved over the years as the computing power has increased and customer demand for more and varied tools has increased. What started out as a DOS program, this is an example of one of these programs. What started out as a DOS program, fairly quickly migrated to Windows, and eventually it's now there are internet versions. Along the way, new types of analyses have been added that go beyond the straight statistics. So things like Cano, heat maps, other project management tools, they've been added into these applications, this software, and the statistical capabilities have also expanded, making more complex analyses available to these occasional users by including guidance on the use, how to set it up, and the interpretation of these things. What's also evolved is the customer expectations of these products. So in the 90s, if you got a new software program that was easy to set up and get running, that was a pleasant surprise. Or in the terms of a Cano analysis, that's a delighter. Today, a program that does not load and start quickly and easily is definitely handicapped in the market. That plus an intuitive user interface are basic tickets into the game. So on the dissatisfier side of the Cano diagram nowadays. So having many available tools was a delighter in the early days that's now migrated more to a satisfier. So the more tools that an application has, the better the application is viewed. One thing that stayed constant over the years as a delighter is what we're calling project direction. So what I mean by that is the program continues to grow into more and broader applications, becoming more of a one-stop shop for analytical tools. Whether they're the statistical tools, lean tools, project management, change management, or something else, as long as it's still, people are delighted by how some of these programs are expanding. The other delighter that's sort of come into view is what we're going to be talking about today, which is analysis intelligence. So this is the built-in guidance on what tools to use, how to set them up, how to interpret them, how to interpret the outcomes. They're reaching a level that is often unexpected and definitely appreciated. So we'll discuss where we think this is going in the future, the future of what's going to happen with analysis intelligence later in the webinar. So what is the what's the focus of what we're going to talk about today? So Stat Analytical published an article comparing R and Python in 2019 that developed the segmentation that's shown in this slide. So it's a good way to show what the target audience is of what we're calling stats for the masses statistical packages. So they're focused on statistical analysis users without a background or an interest in programming, who need well-established tools to address real-life applications. So this is where we're going to be focused for the rest of the webinar on that group of the sort of ease of use, comprehensive for the occasional or non-expert, non-statistician user. So if we talk about this stats for the masses, so over the years, statistical analysis has evolved from experts with hand trucks loaded with computer punch cards standing in line at the computer center to an accessible software running on desktops. So those desktop applications have further evolved from expert to general users, and from generally user hostile interfaces to intuitive graphical interfaces. They've also migrated from standalone programs to things like Excel add-ins and web-based versions that allow porting of data from multiple sources into the program. The most recent step is this built-in analytical guidance, or the analysis intelligence we'll talk about as we go through the rest of the agenda today. So Jim.
Yeah. So just getting back to the agenda here, challenges of statistical applications for the masses. We'll just hit a couple points here. Excuse me. One of the common misuses of statistics. There's this John Spacey wrote in April of 2019, a very, very good article, very simple article that I would highly recommend. That you can find under Simplica by John Spacey. And in it, he goes through and he says, these are the types of things that how statistics can be misused. And the reason we bring this up is because, statistics is based on assumptions, as we know. And if we don't understand what our assumptions are, we're going to make the wrong conclusion from our data. And also the cleanliness of the data, misusing data, all these things are things that can come around and hurt you. So just taking a couple of those. Apples and oranges is comparing things that are not comparable or using unfair or impractical criteria of comparison. So we see this very often when you're trying to overprove a point. This often happens. So no statistical analysis is going to prevent that from happening. So you still do need some type of governance around how you're analyzing your data. Another one of my favorites is overfitting. Too many theories against data, such as random patterns, are sure to be found. That's another one. And again, garbage in, garbage out. Low quality data produces low quality statistical analysis. So all these things still need to be done and looked at. So I encourage you to look at that article and always keep that in mind when you're looking at data. And we always like this famous quote by Benjamin Disraeli, PM of Great Britain. There are three kinds of lies, damn lies, and statistics. So let's make sure that when we use these tools, we don't get caught into one of these. Mark?
Yeah, so while these statistical analysis tools have gotten more user-friendly over the years, there's still a number of challenges that make it difficult for many folks to achieve useful outcomes. The first challenge is the simplest. There's lots of times the statistical analysis is not done even though the data are available. Somebody will use averages or single numbers are reported, and decisions are made based on them when there's more in-depth assessments are possible, leading to better decisions. The second challenge is the fact that most people are not using these tools on a regular basis. They never develop the proficiency to quickly select the right analysis. And when they do undertake one, it takes a long time to work through the steps as the user tries to remember or relearns what needs to be done. So this infrequent use also leads to using the wrong tool. The key step in any analysis is understanding what your analytical objective is. Do you want to see if two samples come from the same population? Am I trying to see if an action has reduced process variation? You know, getting questions like that, getting the objective correct is the first step. But even then, there are many seemingly similar tools, some of which can cause you to draw the wrong conclusion. So what are we going to, so now what we'll do is we're going to try to show how analysis intelligence facilitates statistical applications for those of us who aren't statisticians using these and are not using these tools on a day in, day out basis. So we've got these needs, and so infrequent non-expert users need help. They need help setting their analytical objectives. They need help deciding what data to gather and how to set it up for optimal use. They need help selecting the right tool and setting it up for error-free assessments. So this analysis intelligence uses decision trees, wizards, clear, simple explanations, and other aids built into the analytical software to guide the user through setup, tool selection, and tool execution, thus increasing their speed and improving results. Another thing that happens that helps infrequent users is when there is a consistent look and feel to the tools, or all of the tools, or as many as possible. You want data to be accessed in the same way from a common source. You want default settings that are accurate for most analyses. Input screens where the options are selected all, looking the same. And then you also want it to have like flags that are set when something is not correct before the analysis is attempted. So a verification step in there before you push the button to actually start the analysis. So the goal is to give the user confidence in such that if they can use one tool, they can use most of the others in the analysis program. So that's this idea of the consistent look and feel. So what this analysis intelligence is trying to do is reduce errors and allow the user to focus more on their project and the actual physical things they're working with, and a lot less on the software and the underlying statistics. So what we'd like to do now is to show you statistical software that incorporates this analysis intelligence. I'm going to turn it over to Suresh, the founder and the technical horsepower behind SigmaMagic, a program that helps meet this challenge of statistical applications for the masses. So Suresh.
Yeah, thanks, Mark. I'm going to focus on how analysis intelligence is built into the SigmaMagic software. So SigmaMagic software basically sits on top of Microsoft Excel. So Excel itself is a very powerful tool. It's used by millions of people worldwide. However, there are some gaps if you really want to use Excel to perform some complex analysis. And that is where SigmaMagic comes in. There are three main points that I would like to make. The first is that SigmaMagic contains a wide range of tools. So you don't really need to use a different software for a different application. SigmaMagic have hundreds of tools, both basic and advanced tools that you can leverage and apply to any project. The second point I would like to make is that SigmaMagic has been designed to have a logical and consistent structure so that the users have a shorter learning curve. The architecture is designed in such a way to minimize the number of clicks to get an analysis done, while at the same time providing the expert user with the options to do more complex analysis. And finally, SigmaMagic has built-in analysis intelligence, which helps the users in performing the right analysis and drawing the right conclusions. In the following slides, what we will do is we'll take a look at some of the tools that are built into the SigmaMagic and show you examples of how analysis intelligence is built into the software. So this particular screenshot shows a wide variety of tools that are currently available within SigmaMagic. There are tools that you can use to perform data analytics. You can leverage the power of our software to perform the analysis. For example, neural networks. There are tools related to deploying change within an organization, like stakeholder analysis. There are tools related to graphical analysis and visualization of data, as an example, Pareto charts. There are tools related to lean deployment, such as value stream mapping. And there are tools related to continuous improvement projects like FMEA and Kano analysis. And finally, it has all the statistical tools you would need on a typical Lean Six Sigma project, including Monte Carlo simulations. Of course, you don't need to use every single tool that is shown on this particular slide. You basically pick and choose the tools based on your project objectives, but it's good to know that a wide variety of tools are available in case you need them. So what we're going to see here are on the next few slides are examples of how analysis intelligence is built into SigmaMagic. So I've taken an example of a control chart. So I think most of the tools are very similar. So the look and feel of one particular tool is similar to the other tools that you're going to look at. In the past, if you had to perform an analysis, you had to use different software applications for different needs. So the trend now, as Mark mentioned, is that most of the tools or majority of the tools are available in a single application. So in some applications, if you want to create a control chart, you first need to decide what analysis you want to perform. So if you want to do an IMR chart, you go and select an IMR chart and perform the analysis. Or if you want to do an X bar R chart, you go down the menus and pick the X bar R chart and do the analysis and so on. Within SigmaMagic, all the control charts are in one place. In fact, this particular screen actually covers 14 different control charts in a single dialog box. The way it is structured is that when you pick the data type as continuous, all the control charts that are related to the continuous data sets are shown under the chart type. If you basically pick a discrete or a defects as a data type, it will show you the appropriate control charts for defects and defectives and so on. So your selection of your menus basically dictates how this particular dialog box basically reacts to you. In fact, you don't even need to pick a particular control chart using SigmaMagic. The logic of how an expert would basically pick a chart has been programmed into the software. So what you can see on the screen here, the chart type has been selected as auto. If you leave the chart type as auto, the software will basically use the logic that has been programmed in and pick the right chart for you. So this is one example of analysis intelligence that is built into the SigmaMagic. As I mentioned earlier, there's a logic that has been programmed into the software. So here is an example of a logic. So for example, if you're working with continuous data types, it basically follows this particular flowchart and says, okay, depending on the subgroup size, for example, let's say your subgroup size is between 2 and 9, it would basically pick an X bar R chart. So the advantage of this particular approach is that this tool can be used by beginners. So if the beginner is not really sure what specific tool to use, they can always use the auto setting and the flowchart will pick the appropriate tool for them. At the same time, if you're an expert and you know exactly what you want to do, you can always override the system defaults and perform a different analysis based on your needs. A second example of how analysis intelligence is built into the software is for data selection. So what is shown on the screen here is how SigmaMagic basically picks data for analysis. SigmaMagic uses data in tables. These tables can be extracted from a wide variety of sources, such as other Excel files, SQL databases, cloud, web servers that host the data. So Excel has a lot of powerful tools that can pull the data from different sources. You can merge it, modify it as required, and convert it into a table. Once you have your data in a table, SigmaMagic uses the data from a table to perform the analysis. In the olden days, we had to specify what type of data you're working with. For example, we had to specify, okay, this is the text column, this is the numeric column, this is the date column. SigmaMagic has built-in intelligence where based on the data that you select for your analysis, it automatically determines the appropriate data type. The software is also smart enough to know what type of data is expected for each analysis. So if you pick the wrong data, the software will not even let you perform the analysis for that particular data set. If you have missing or incomplete data sets, it highlights those as red text boxes on this particular screen. Another example of analysis intelligence is shown on this particular screen here. So this is where you specify the tests for your control charts. So not just for selection of the control charts, we have the auto feature here, for example, to calculate the control limits as well. You can set it at auto and the software will basically determine your control limits from your data, or you can set it as manual and then you can specify your own control limits. Similarly, the test for special causes, there are a lot of different standards that have been programmed into the software. So for example, the AIAG standard or the Westcard and so on, you can pick one of those standards and use those to perform your control charts. Or if you're an expert and you know exactly how you want to override them, you can specify those as well. The next slide here basically talks about the default access labels, titles, limits, and so on, which are also automatically determined by the software based on predetermined rules. And it gives you an opportunity to override them in case you're not happy with the values selected by the software. This minimizes mouse clicks, which has been one of the guiding principles for us on how this software has been structured and designed. And finally, this particular slide talks about a verification of the inputs that you have entered to perform your analysis. So here's another example of analysis intelligence. The software is constantly checking if you have correctly specified the inputs for your analysis. In case it finds any issue, it will clearly highlight on this particular page and give you guidance on how to correct your problems you encounter even before you generate your analysis results. If everything is okay, you get a green check mark as shown here that everything is fine and you can confidently proceed to perform your analysis. So the previous few screens, we talked about how we were using analysis intelligence to provide more guidance and support to the user so that they perform the analysis in the right way. What I'm showing here on this particular screen are some results, sample outputs from the software. A lot of statistical analysis we perform are based on assumptions. Some people forget to check the assumptions, thereby invalidating the software analysis results. For example, some analysis can only be performed if the data is normal. Some analysis requires a minimum sample size. A few analyses can only be performed if the input variance between different groups are similar, and so on. If you are not checking for these assumptions, the results or your conclusions might be incorrect. So what we have done in SigmaMagic is we have programmed these assumption checks into the software, as you can see on the screen highlighted by the arrow. The software will check for automatically check for these for you. And if there is a problem, it will highlight those so that you can take corrective action and not report incorrect results back to your management.
So Suresh, would this then tell you to normalize the data, do a box-Cox transformation, or try to find it before you use this control chart?
Yeah, so if you select the methodology as auto, for example, it will actually do the auto correction for you. So in case the data is not normal, it might use a box-Cox transformation, or it might use some sort of a transformation of your data and perform the right analysis.
Great, thank you.
So yeah, thanks. The following slide here basically shows about importance of having clear conclusions. In the older days, some of the softwares were only reporting the p-values. And the assumption was that the person who is looking at the report can correctly interpret how to look at the p-value and make the right decisions. So there's no point in reporting p-values and then just stopping there. So within SigmaMagic, all the conclusions are very clear. So the person who's reading this particular report will not make a mistake interpreting the results. So this is one of the ways intelligence has been built in so that a person using these reports, the conclusions are clear, and so that they use it properly when they are doing the analysis. I have a few screenshots here. So basically some outputs just to give you a flavor for what are the different types of results that you might expect. On the left-hand side, we have a Pareto analysis that is performed. So this is a standard Pareto analysis that you would get from other softwares as well. The middle figure basically shows an output from a gauge R&R study. And you can see here that some sort of an intelligence has been built in because the green, red, and yellow areas clearly highlight whether you have a problem or not. So instead of just having a plain figure, it just gives you some outputs. So it also gives you a visual clue whether your gauge R&R is acceptable or not acceptable. And a few other examples here, gauge run chart. Similarly, on the next slide, we have some examples from a box plot with superimposed data points. And the central figure here talks about some sensitivity analysis results from Monte Carlo simulations studies. And the figure on the right is basically a histogram with the best fit curve. So the software has a lot of different distributions built in. So when you have the data, it will automatically fit the best distribution for you and then perform the analysis based on those. So so what I have basically taken you through is a quick snapshot of what the software can do and some of the ways in which the intelligence has been built into it. So, so with that, I think I would like to basically thank you for giving me this opportunity and hand back to the moderator.
Yeah, just we do have a couple questions in from the audience. One is, does SigmaMagic offer training classes online?
So we do have some online material that's available. So there's some e-learning modules available online as well. And we have some partnership with a few vendors who provide training, which includes online and offline. So we can connect you with those providers to do that with respect to online classes. But usually what we usually do is for purchases of our software, we provide a free 4-hour online session to help them get started so that they can get up and running quickly.
Great. And the next question is whether process capability calculation needs normalized data always, or even if the data is non-normal, the results are valid.
Yeah. So yes, process capability calculation, if you use the auto feature, the software will check whether the data is normal, and then it will perform a transformation for your data before it computes your process capability analysis. But if you are in the expert mode and you override that and say, I do want only a normal analysis to be done, then it will provide a warning for you under assumption checks, but it will continue to use what you have requested. So auto feature helps you to do the transformation automatically.
Excellent. With that, we're going to ask the folks online to rank and order the tool they would like demonstrated by Suresh. We got box plots, Pareto, hypothesis testing, normality charts, distribution identification, Monte Carlo, or an analytics tool, decision trees using R. So quite a varied set of things for Suresh to walk us through. So if you'd go to the poll EV there and respond in the ranking, use the up and down arrow on the left to move your choices up and down, and we'll go by what you say. Right now it's box plots coming out #1. Maybe wait a couple minutes to see if it changes with some more people participating. We can start with box plot and you can keep on participating, and then we'll keep track of the next one. So distribution identification. Ooh, now it's switched a lot. All right, so hold our breath there. So you want to go ahead, Suresh, and just take over the screen and walk us through distribution identification. That's a fun one.
Yeah. So I hope all of you can see my screen.
Yep.
So what you have is when you install the SigmaMagic software on your computer, you will get an icon that says SigmaMagic here within Excel. And this is a standard set of icons that we have, or buttons that we have to perform the analysis. I have some data that is preloaded here. So I'm going to use this particular data for the demonstration here. But the basic thing is that the data can be pulled from any source. So the only requirement is that the data has to be in tables. So each of this is a different table here. So I have a data here for paint concentration. I have some data for diameter, call center wait times, yarn strengths. So we have a bunch of different data that we can use for our analysis. So what I'm going to do here is just to give you a flavor of performing the distribution identification. So all of our tools that you would need to perform an analysis are under the tool wizard. So you would need to click on the tool wizard here, and the tools are basically structured in one of these 6 buckets. So you can actually do a search and pick distribution identification, but I know that distribution identification is under stats. So if I click on stats here, it lists a bunch of different tools that are on this particular screen for distribution identification. And I have identified distribution as one of the buttons here. So I'm going to pick that. And when you pick a particular tool, the SigmaMagic software will add this particular tool to your workbook. So it is basically added the distribution as one of the worksheets within my analysis. And if you look at Minitab, for example, they only have distribution identification for continuous data. So in our case, we can handle distribution identification for both continuous data and discrete data. We have more number of distributions here compared to what Minitab has to offer. And if you have a specific distribution that you are interested in, you can always get in touch with us and we can add more distributions to this if required. But this is the most commonly used distributions that you would typically find most of the people using anyway. We have two different approaches or algorithms to specify distribution identification. So we have the Anderson-Darling approach for the goodness of fit, and we also have the chi-square approach for that. So we can pick one of those. So I'm just going to basically leave it at default. I'm not changing anything on this particular screen. I just shared with you some of the options here, but I'm just going to leave it as is. Go to the data button here, and I need to pick the data for which I need to do the distribution identification. So I'm just going to pick one of these, which is the diameter data. So I have a lot of different data here in my data tables, as I mentioned. So I pick the data or the column for which I need to do the distribution identification for. So in this case, it's a diameter. There are 40 rows of data for this particular data set. So that is pretty much all I need to do. So it's basically one click. I just have to go to the data tab and just select my column, and I click on OK, and distribution identification is done. So that's one of the design objectives, was to see how we can minimize the number of clicks in order to perform our analysis. So the output here basically shows you a histogram of your data with the fit. And here is using the Anderson-Darling method. It has basically fit all the different distributions here. It has the Anderson-Darling statistic, the p-values. And for those distributions that fit the data, it has basically said an OK, saying that these are the distributions that possibly fit your data. And then the best distribution that fits the data is a log logistic distribution here. So the p-value is given, and the parameters for the log logistic distribution is also given here. So you specify that, and the conclusion clearly says that the log logistic distribution best fits your data. So that's a quick example of how you would perform distribution identification. And if you go back to analysis setup, all of your options are still here. You can override them if you like. So for example, if you want to pick only bounded distributions, you can select that. Or if I wanted partially bounded distributions, it will only pick those distributions that are bounded on one side and unbounded on the other side. So if you have some prior knowledge about what side of distributions best fit the type of data that you have historically had in the past, you would basically pick those, or you can manually select the distributions that you are interested in. And when you click on OK, it will basically use the selected subset of distributions, and it will basically fit only those distributions that you're interested in. So that was a very quick snapshot of how we would perform distribution identification using SigmaMagic.
Yeah, I have to comment, Suresh, I love the partially bounded and putting that into play, because that is sometimes a big headache when you have bounded. When things are bounded, you don't know what to do, how to manage that. That's really a lot of added value and a lot of saving quite a bit of time. Very nice feature.
Yep. So thanks. Any other further questions on the distribution identification?
So the second one is hypothesis tests now.
Okay. All right. So so that was an example of distribution. So I'm just going to switch over to hypothesis testing now. And in order to perform hypothesis testing, I need to basically add the appropriate template or tool to perform the analysis. And again, it's under stats. And all my hypothesis testing is under compare samples. So there are actually 14 different hypothesis tests, everything built into this one single template. So if I click on compare samples, it basically adds a new tab for me, which basically performs hypothesis testing for me. So again, depending on my choices here, the appropriate tests are displayed. So for example, if I have continuous data and how many samples I want to compare. So if I click on hypothesis here, only those tests that apply for continuous data are listed here. For example, 2-sample T, ANOVA, PED-T, Kruskal-Wallis, Mann-Whitney test, Moore's median, ANOM. So all of these tests are applicable for continuous data. So if I go back here and say, for example, I have working with defects, and if I go to hypothesis, then it will only list those tests for me that are applicable for defects and so on. So So that's how some analysis intelligence was built into this particular package. So in order to perform hypothesis testing, again, I have not changed any options here. So this is the default options that are available right off the bat. There is also a flowchart that is available here. So this particular flowchart shows you the logic. If you have selected auto for selection of the tests, it basically shows you the logic of how it's going to pick a particular test versus the other test. So I'm just going to leave that at the default. I'm just going to select my hypothesis test as auto. So I would let the system pick the test for me in case I'm not sure what test to perform. And all I have to do is basically pick my data. So here, for example, I can specify 2 different columns of data here and compare them as a hypothesis test. Or if I have a group type of data where I have 2 different columns in a different format, I can also specify that. I can change my input type to group data if I like, and then I can specify the analysis variables and categorical variables. The reason they are shown in red is because it's saying that, okay, I'm expecting a data there. I don't have the data, so it's shown in red. So as soon as you pick your data, it basically gives you a visible indication that, yes, I think I'm happy with this particular data that you have selected. Here, for example, I want to use this particular column before and after. So once you specify the data, that's pretty much it. So I think I click on OK, and it will basically take that particular data and perform the hypothesis test for me. So you can see here that it gives you the hypothesized p-plots, confidence interval plots, box plots on the left-hand side. On the right-hand side, in my notes section, it is telling me that it has basically picked the 2-sample t-test. I had selected auto, but it checked my data was normally distributed. It's reporting what hypothesis test it's performing. So the means are equal, means are not equal. It's giving me some sample statistics information here, the t-test, p-value, and confidence intervals. And there's a clear conclusion at the bottom that says that there's no reason to believe that there's any difference between the before and after for this particular data set. So this is a quick example of a hypothesis test. And again, I just had to have 2 clicks, and basically I was able to perform this analysis. But of course, if you are an expert and you want specifically to do some specific analysis, you can always go back and override these options and do a more complex analysis if required.
Did it perform a variance test also?
Yeah, if required, it will also perform a variance test and compare.
So it already had, can you show where in the log it shows that?
It currently doesn't display that, but there are 2 different algorithms that it uses. So if the variances are unequal, it will basically use a different algorithm to calculate the value, and if they're equal, it uses a different algorithm to calculate the value.
Okay.
For pooled standard deviation versus independent standard deviation.
So you don't need to do the variance check because it's built in.
Yeah, you don't need to do it, right? Because the auto will automatically do it for you at the background.
Nice. Okay, good. All right, we have time for one more.
Why don't I think
Or do we want to wrap up?
go ahead and with these 2, there's I think there's some interesting stuff Suresh has on where analysis intelligence is going. I think that shows up in the next slide. So
great. I will take over the screen here.
So while that's going on, one question that came up is for process capability analysis. Do the data have to be normal for the software to calculate process capability?
Yeah, I answered that. So it doesn't have to be normal. So if it is not normal, it will perform a check and it will pick the appropriate way of.
So I'll do a box cox on it and then normalize it and then do the analysis. Is that right?
I think that there are some different options. So I think it currently uses, I think it fits the best distribution to the data, and then it uses that distribution to calculate it.
Okay, good.
Box cox is not always good at
it doesn't always work. It's not foolproof. Yeah. I agree. I agree. It's curious how you handle that. Thank you.
Yeah, it uses the best fit distributions. Yeah.
Okay. Back to you, Suresh.
Okay, great. So, so here is a vision for how the software is going to evolve in the future. So what you have seen so far is some analytics intelligence that was built into the existing software. But if you think about the future, maybe a few years down the road, so we now have access to a wide variety of data. So it could be supplier data, the data coming from multiple places, the design, manufacturing, customers. So we have access to a lot of data in today's world. The first step is to make sure that the data is clean. So we extract the data, we clean it up, and we store the data in a data warehouse. So all the logic that experts use to solve problems basically is available to us. So these can be programmed into the applications, and the software is now smart enough that it basically can automatically look at all the different types of data that it has and try to build relationships between the data, perform the different types of analysis automatically. So in addition to these, we also have access to tools such as advanced machine learning and deep learning, and those can also automatically parse through the data and build models as well. So these background processes can be constantly running in the background, and if the software finds something interesting or something out of the ordinary, these results can then be thrown to the business user for further action. So for example, it can be constantly analyzing the data and said, okay, the supplier incoming quality has been getting worse over the last couple of days or last week. Maybe you want to look at that, or maybe the vibration of this particular machine has been increasing beyond some levels. Maybe you want to request for maintenance and so on. So what we are expecting in the future is that the analysis is going to become more proactive rather than reactive. In today's world, for example, only when there's a problem, then somebody is going to launch a project, assign it to a black belt, who's going to basically look at all the data, perform the analysis, and then make some recommendations. So I think in the future, the way things are headed is that the software is going to be running constantly in the background, constantly performing the analysis, and only when there's some exceptions, it basically throws that out to the expert users to basically validate what it has found, and then basically take that and take some corrective actions based on that. So some of these tools are going to be built into the next version of SigmaMagic that we anticipate in version 16, but I think this is where the future is heading.
Okay, so hopefully we've shown you that SigmaMagic is an excellent example of what this analysis intelligence, and it provides decision support, that consistent look and feel, and a broad range of tools necessary for many improvement projects that we undertake in business today. So it's designed to ensure the correct tool selection, with the correct data at the right time for doing that particular analysis. So I think with that, Suresh, I think it's back to you about how this is available.
Yeah, so thanks, Mark. So as they say, seeing is believing. So, but actually trying it out is even better. So why don't you check this out for yourself? So there's a website address given at the top, sigmamagic.com. All you have to do is visit the website and you can download the latest version of the software. And when you do download it, you get a free 1-month trial of the software with full functionality. There's sufficient help and e-learning content as well to help you get started. So if you're interested to purchase it after you try it out, the software is very affordable as well. And it roughly translates to about $200 annually for the cost of the software. And this includes some free training as well. So we have other services that might be of interest to you based on your needs. So if you need some help with training your employees, I think we can help connect you to the right resources. We can help you migrate your existing training materials to SigmaMagic if you like. And if you need some consulting or training support, we can help you there as well. So with that, thank you. And you can always feel free to reach out to us if you have any questions regarding this.
Thank you, Suresh. Thank you, Mark. If there's any other questions, we probably have a couple minutes to take on any questions that are out there. But as you can see,
so there,
go ahead,
Jim,
Mark.
there was one question in there, which was that there is a power of test which is defined, how that is done since the sample size is predetermined.
Yeah, so if I didn't really talk about it, but one of the inputs that we have in compare samples is there's a place for us to specify what is the difference that is practically important. So I had not specified that, but if you enter a value for the difference that is practically important for your analysis, it will also do a sample size check. And under assumption checks, it will report out saying that do you have sufficient samples or don't you have sufficient samples? and it also tell you how many samples you need to perform your analysis. So that's how the sample size check has been built into it.
Okay.
That's nice.
Thanks.
That's a nice feature. Definitely. Any other questions, Mark, that you see?
No, I think that's what we have in terms of the questions in the chat. And Jim, I think it's over to you to wrap us up.
Yes. So again, thank you. Hopefully you found this webinar interesting. I think this is a very affordable tool off a very simple platform of Excel. I've seen other Excel add-ins. I think this is definitely a step above anything out there. So, and it's very affordable. So something to definitely consider in your toolkit to help you solve problems. With that, we're thinking that there's a lot of different applications for these statistical analysis tools that Suresh developed. And so we identified some of the more common type of challenges out there. We are open to gaining your feedback on what you think is most interesting. But we thought that these might be very interesting to you. So look out for those upcoming webinars in the future. And with that, I'll just close it out as behalf of EIG. As I said in earlier, we're 50 consulting companies of consultants, solution providers, and SaaS providers like SigmaMagic. So please check out our website. We have over 50 webinars, over 50 courses, and over 50 companies that are there to help you solve your technical problems. We're here to help you generate self-funding and self-realization tools. And with that, I'll just close it out and ask Suresh and Mark if they have any closing comments. Mark first.
No, I think this is every time I deal with this software, I learn more and I get even more excited. So
Likewise, Suresh.
No, I think it was a good session. So thanks to all of the people, audience who have asked questions as well. So thanks. I think it was a good session for me.
Great. Thanks for everyone for joining, and please feel free to follow up with Suresh or Mark directly or me to answer your questions about this software. And don't forget to go on the SigmaMagic website to get your free version for 30 days. Thanks, everyone. Have a great one.
Thank you.
bye-bye.
Bye. Bye.